Okay, so forming ionic formulas. There's some rules that ionic compounds or metal ions are positive polyatomic ions with mono or polyatomic ions. The positive ion is always written first. Don't switch that. The subscripts are going to be such that the charges added to be zero. That is, the positive charge has to equal the negative charge. The subscripts need to be the smallest set of whole numbers possible. That is, you don't write Na2Cl2, you write NaCl. So let's consider the formation of Al2O3. Aluminum loses 3 electrons to become Al plus 3. Oxygen is going to gain 2 electrons to form oxygen minus 2 charge. However, those charges have to be equal. So if aluminum only loses electrons in 3s and oxygen only gains electrons in 2s, I need to find the least common denominator between the two, which is 6. So aluminum needs to lose 6 electrons, 2 times plus 3, and oxygen needs to gain those electrons, 6 electrons, and that's 3 times minus 2. So you got plus 6, you got minus 6, it cancels. The formula works. So 2 aluminums need to lose electrons to form 2 aluminum plus 3s, and 3 oxygen atoms need to form 3 negative 2 oxide ions. Therefore, the formula is going to be Al2O3. There are some tricks I can show you. So let's look at these two questions. And I'll go ahead and work through some of these study questions and maybe do a couple more. So we want to get the formulas for the ionic compounds for the following ions for both questions, and we'll work through some of those on paper for you. All right, so let's look at these formulas from these ions. So what is that going to make it? One trick is to consider the number, and if I write the 1 in explicitly, you're going to take the number without regard to the sign and then switch them. That doesn't work in a couple of cases, but it works in this case, and I'll show you a case next that doesn't work and where to be careful. But then we would say the formula is AlCl3. Now, if I try to do the crisscross thing with that, what I would get is Ca2O2, which isn't going to be right. We're going to reduce that and call it CaO. We want the smallest set of whole numbers possible. It also comes in cases where you have one charge that's a whole number multiple. It happens a lot when the charges are the same but bigger than one, or one of the charges is a whole number multiple of the other. Sometimes that happens, but just make sure you reduce those out. If we crisscross these, we're going to get MgI2. Then when we do these, we're going to get Na2S. Now here we've got one that's got a polyatomic ion in it. That means I'm going to need 2 nitrates, but I need 2 of that whole thing, and then 1 lead. So PB, then we're going to put the nitrate in parentheses, NO3, and then we're going to put a 2 on the outside of the parentheses, indicating there's 2 of that whole thing. You don't need the parentheses if you just have 1 of them, but if you got more than 1, you need to put parentheses and a number on the outside, so everybody knows you mean 2 of that whole thing. You got these, again, you would end up with the crisscross, you'd end up with Al3P3, but that's not going to be right. You're going to reduce that to ALP. Now here's a plus 1, minus 1, so I just got 1 of each, but so it's going to be AgC2H3O2. And note I did not put parentheses on that one because there's only 1 of them.